Okay, then I think let's start, huh? Bismillah ar-Rahman ar-Rahim. Hmm? AI. Yes, it is AI. No. It's the first topic was NLP, maybe you. So this is if you are not forgetting. So the last CLO is about first NLP, about AI domains. So the first we talked about the NLP, and now we are talking about machine learning, and then at the end we will talk about deep learning. So NLP we ended already, and so now we are going to take an introduction of this machine learning. So, mm, so on this slide, uh, you are seeing the definition of the machine learning by Tom Mitchell. So he said that machine learning is something, a study of computer algorithms, but these algorithms, when you will code them into programs, then these programs will automatically improve through experience. So these programs will do what? Automatically improve their learning through experience. This is the definition of the machine learning. So now, if we will just a minute, I have to set this annotation. This annotation is still coming on. Okay. So this was the definition. And now, what is the need of machine learning in our society? So the first major reason is that we want to make decisions in our real life, but these decisions will base on the data that we will collect. So, and if that sometime that hit, not sometime, actually our when our data is large and we want to take decisions from that data about anything, then we can make these decisions with speed. So that's why the word is efficiency. So that's the word is efficiency. So we can make decisions with speed and on the large amount of data. So that's why you have this word scale. Scale means the size of the data or the size of the project. So when we want to make decisions based on the data, then uh, if we are in the field of computer science, then we need machine learning. Similarly, uh, if we are in the business industry, then sometime we want to see the trends in customer behavior, how the customers are, for example, buying different things. Or so if you want to see these different habits of customer behaviors or customer attitude, then you can also use this machine learning. Or similarly, if your business is running there and from the data, maybe you have the sales data, or you have the stock, which you can call it inventory or whatever. If you want to study any kind of patterns from there, or any kind of something, for example, maybe your business is going down and you want to identify that what is the reason, and if you have that data, then you can see these trends that why your business is going down. So, or similarly, if you want to increase your business, and for that you have to introduce new products, so you can also see your data first, and then you can identify that what kind of different things that you can introduce. So So there are different techniques available in machine learning which you can use to view the trends of the customer behavior. Now, this is the formal definition of the machine learning model. That is not a different thing from the definition that you already saw in the beginning. So we talked about the computer programs in that beginning. So now we will say that computer program is something that will learn. We know that will learn automatically. From what? From the experience. So here experience means basically data, okay? Or you can also give as the some other name as the division in machine learning. You will see, but a computer program that will automatically learn from experience with respect to some task. So you have built that program for some task, maybe for spam or not spam email detection, if that is your task. So your task can be spam or not spam email detection. That is the example of classification. So your task is, for example, now classification. Then your computer program can learn for that task from the experience. And that learning you can measure through the performance measure. And that learning of that computer program you can measure through the performance measure that we are calling it P. So now, up to this point, we are saying that computer program, we can say that computer program is learning if that computer program is learning through experience on some task, and if the performance measure is P, and if that performance measure P at that task or whatever, if that performance measure is improving, that performance measure uh, can be accuracy, can be F score, can be precision, can be recall. These are the different formulas through which you can calculate. I am saying generally, through which you can calculate the accuracy of your model. So if your performance of the model is improving with experience, then you can say that your computer program is learning. If performance measure is not improving, then it is not learning. So basically three things are involved: task, performance, and experience. Now we are going to explain them, uh, not in that way, but there was a slide here, maybe it was deleted, I don't know. So I don't know, I will check it later on. So our experience is what? So our experience is what? Here in this definition, our experience is data, particular example. But you can also call it that in machine learning, it can be supervised learning, unsupervised learning, reinforcement learning, semi-supervised. These are the four divisions. But anyhow, leave it. Experience is your data, huh? Is your history or something like that. Task is what type of task you are performing. Either you are performing clustering, either you are performing some regression, either you are performing some dimensionality reductions. So these are the different divisions in machine learning, divisions of tasks in machine learning which you can perform. And performance measure is what? It is a kind of a formula through which you can calculate something related to accuracy of the model. From 100%, how much your model is performing? 97%, 96%, 80%, 75%? What is the percentage of that accuracy? That is one example. But similarly, you can calculate the precision, recall, F score, and there are many other equations through which you can calculate different things. Now, what are the challenges or what are the major issues in machine learning. So the first thing is that if you are going to build a model in machine learning, then the thing that you needed is the quality of data, is the quality of data. If your data does not have the quality, then you will not get good results. So this is the general statement. In this general, if we can talk about only on this topic, quality of data, and then you will see different things, how the data is not having the quality, and how the data, now how we can say that this data has the quality. So that is a separate subject. That is a separate topic on which we can discuss the things. But anyhow, up to that point, so you only have to know at present, you only have to know that if your data does not have the quality, then you will not get the good results. So then, time consuming job. All the models that you will build in this subject of machine learning, especially the models where the data is large, and especially the models like neural network or, or some other probabilistic models. Mostly models you will see in machine learning are probabilistic. So if your data is large, then your model will take time to learn. That learning is, you can say, is called the training phase. So during that training phase, that model will first get trained. That model will first learn from the data, and it will take time. And if you will run on those normal machines, some models are taking 4 days or 5 days in learning in those normal machines that you are using at homes. So some models are taking 4 days or 5 days only for training. And when their training will be finished, then you can give them a test data, and then you can see the actual things. So it is a time consuming job. And then other thing is lack of specialist person. Normally around us, there are many people who are presenting this slogan that we are an expert of this machine learning, but actually they are not. They are only saying those slogans. So actually, we have a lack of specialists in this field, either machine learning. Machine learning is the subdomain of AI. You know that. That's why we are studying it. So technically sound persons know. Theoretically sound, you will see everywhere. Because in computer science, in our field, everybody is saying that I am doing something related to machine learning. So technically, if they are sound or not, that is a different thing. Theoretically, you will see many people. So number 4. So some people who are driving or running their business, and if some problem occurs in their business, they don't know how to remove that problem. Why? Because they don't have any clear objective. That they cannot say that why that problem is coming. So that's why the word is they cannot formulate that business problem. So that's why they don't know how to solve that issue, because they don't have any objective. They only know that this problem is coming, but how to remove that problem, they cannot state, they cannot describe. So that's why no clear objective. And then issue of overfitting and underfitting. These might be the new terms for you. How many students from you, they know that in machine learning or in computer science or in AI, there are some models which has the training phase and then the testing phase? How many students have no? Raise your hands, please. So 1, 2, 3, 4, all, huh? You don't know what is the training phase and the testing phase. Okay. So if you know that what is the training phase and what is the testing phase, that is good. Then you will understand the definition of overfitting and underfitting. So normally in machine learning, or you can generally say in AI, if you have the model and that model is probabilistic, then you have the data for that model. That model is your program, okay? So then you have the data, input data for that program. Normally, most of the time, you have to, your model have to learn something from that data. Your model has to learn something from that data. And when you will run that program or model on that data, that is the learning phase. And the other name for it is training phase. Model will automatically learn things from that data. When that training or learning phase will be finished or completed, now your model is ready to run on the any unseen data. That unseen data means test data. So now you can run any query according to that model. You can run any query of your model, and then your model will respond you. Then that model will reply you, because now that model has finished its training. So when so so that learning phase is called training phase, and when you are testing the data on the model, that is your testing phase. So now issue of overfitting and underfitting. So if your model is performing good on training data, if your model is performing good on training data, but not on test data, that is called overfitting. That is called overfitting. Again, if our program is performing good on training data, but not on test data is actual test, huh? So then it is called overfitting. And similarly, what is underfitting? When our model or program is not performing good on training data. When the training is not good, then automatically testing would not be good. So that is the category of what? Underfitting. Underfitting. Now, the next, curse of dimensionality. Curse of dimensionality. So curse, I don't know what is the meaning in Arabic. So maybe bala or something like that. I don't know. In my language, it is bala. Maybe in Urdu, or maybe in Arabic, it is bala. So curse of dimensionally. Uh, or maybe you have another word, lana. Huh? So you can say something like that. So curse of dimensionality. Dimensionality is something uh, about size of the data. So this curse of dimensionality is something, a concept about the size of the data. When you have the data on which your model have to run, in your data, if that data is now in a tabular form and you have many columns in it, and you have many columns in it, if I say your data is large, if I say generally, I can say, but now I am giving you an example that if your data is in tabular form and your data has many columns, so those columns, when you will convert them into the form of vectors, vector is what? One-dimensional array, which will contain the names of your columns in the data. So if you have many columns, then it means now the size of your data is large, because those columns will contain rows. We are supposing that those columns will contain rows of entries or whatever, and we have many columns. We can represent those columns into one-dimensional string type array, and that string type array will contain what? The name of these columns in it, and that one-dimensional array would be called vectors. So now in this vector, which is a one-dimensional array, we have many names of the columns, which is representing the size of our data. And normally when your size of the vector is too much, then the model will take too much time in learning. Then the model will take what? Too much time in learning because you have many columns. So increase in vector dimensions. So if the size vector, you can say array, one-dimensional array. Huh? So increase in the size of the vector, it will cause what? Increase in data exponentially. The meaning of this sentence is that when you will have many columns in your data, that columns will automatically have the entries, then your model will take too much time in learning. How you can say this in technically? That is the technical sentence. That increase in vector dimensions. So if the size of the vector is increasing, then then your data will also increase exponentially. X raised power square, this is exponent. X raised power n, this is exponent. If n is the size of the vector, then I can say x raised power n. So we don't know where it will go. So generally, what is the meaning of this sentence? We should have to take an optimal size of the vector. And if the size of the vector is large, then it means our data is large and the model will take too much time in learning. So that is the topic of curse of dimensionality. Then difficulty in deployment. So these models that you will build in machine learning, it is not easy to deploy. Deploy means now you have finished the product, your software is now completed, everything is okay. Now you have to install this software in the company or in the industry, and then it will work. So this is called deployment. So these models, some models are very much easy, but when you are going to deploy these models, then you will face also difficulty and etc. So these are the general statements that you can say about machine learning. And now what are the applications which are available in machine learning? So NLP, machine learning, deep learning, application wise, you will see almost the similar things. Okay, almost the similar things. So now, so one of the applications in machine learning is emotion analysis. What is emotion analysis? For example, you have some text or you have some speech. After analyzing that text or speech, you can say that that person is happy, surprised, or his mood is neutral, sad, angry. So this is called, you are identifying the emotions through the text or the speech. This is the application of emotion analysis. Similarly, sentiment analysis. So sentiment normally means comment, opinion, okay, something like that, or feeling. So sentiment analysis normally, the models in which you are doing some sentiment analysis, then normally you have 3 or 5 or 7 categories in that. And one example is given here. If you are going to identify, for example, on Amazon, and there is a rating of the products there, and you want to identify that the rating of this or the feedback of this product is positive, negative, or neutral. From after looking on the feedback of the about that product, if you are going to identify that the feedback is positive, negative, and neutral, this is an example of sentiment analysis. Okay, this is an example of sentiment analysis, because you are going to analyze the opinions of the people, or the comments of the people, or the feelings of the people. So this is something mentioned here: positive, neutral, negative. So that is about the product. The product can be positive. Feedback can be positive, negative, or neutral. If you will say, for example, here, great service for an affordable price. So that is normally a positive sentence if you are looking at the feedback of a about a product. We will definitely be booking again. So maybe this is the sentence for the hotel booking. Huh? You have booked a room there, and now and after um, leaving the rooms, then you are giving your feedback that we will definitely be booking again there. Similarly, here, neutral, just book 2 nights at this hotel. This sentence is not saying anything positive or negative. Similarly, horrible services, the room was dirty and unpleasant, not worth the money. So this is negative. So your model will read these sentences and it will automatically detect that this is a negative sentence or positive sentence or whatever. So that is called sentiment analysis. Similarly, error detection and prevention. So detection of error and then how to prevent that error. So for example, that this is the data is coming and here this is the data we received. This was sent, this was received, and here we have a difference. And here we have a difference in these bits, which means that some error has occurred when you are sending this data to the destination. So at the destination, you receive some data with the errors. So error detection and prevention. So this is also a topic of machine learning or an application of machine learning. Some people who are doing this in the field of networks, okay, that is in the field of networks, they can also detect errors and prevent them because machines are communicating with each other. Or it can be also some other application. It can also be some other application, maybe some speech analysis, and in which you are analyzing speech and then you are analyzing where we have some error in that speech or something like that. But that would again be about some speech data. Huh? So similarly, you can use, you have seen some application related to weather forecasting and prediction. So this is just a diagram given to you. You don't have to understand this diagram. So here, this diagram is just giving you an idea that here we are taking the data. We are the what type of data, target time, what was the time, date and time, elevation, height. Huh? So longitude, latitude, radar. So you are taking different data from these different things into the form of images or maybe some textual data or whatever. Then you are applying convolutional or CNN, convolutional neural network over it. And then you are downsampling it, spatial downsampler. What it is saying, this is not needed to understand, okay? We only have to see that weather forecasting and prediction is one application of machine learning. But if you are looking at this picture, then at least you can understand what is something going on there. So here in convolution down sampling, so this is the size of the data which you are reducing here, okay, which you are reducing here. If the image size is large in the beginning, then you are reducing into smaller size. So this is what that spatial downsampler is doing something here. And then convolutional LSTM, temporal encoder, you are doing something with the time here. And then this is attention block. Maybe you have heard this transformer based something. So that is attention here, which is the part of this network here. And finally, we are predicting something like that within this time. And this image will predict the weather, whatever it is. So here in this model, we are simply using some neural network here, and then we are predicting something. Similarly, we can say that we can analyze stock market, and then we can predict that in the next week or in upcoming days, the stock market is going to fall or going to rise, something like that. Similarly, you can do speech synthesis. What is speech synthesis? Speech synthesis is when you are speaking, then your model is understanding your accent or pronunciation or whatever, and then it is converting into some other voices or your own voice, uh, with a different style. So here we are not converting the speech into text. No, here we are converting our speech into some other dialect or into some other style. So if you will see here, so s- someone is speaking here, and then automatic speaker model construction. You have a database here, database of speech. You have different samples of speech here. So from your speech, now you are identifying your features, and then you have reading, narrating, emphasizing these different styles. How reading the text, narrating the text, or emphasizing the text. You have these different styles here. So here you are giving input to your model, and then speech synthesizer, it is creating different styles of your input data, removing noise and giving you finally that whatever you have given input, it is giving you finally that text into reading, narrating, and emphasizing. Now, from this picture, what you have got the idea. This is this is also the input to the model. This is also the input to the model. So if I have a model, I can take the voice of Skandar. I can take the voice of Abdullah or Hamza. I can take all these voices through here from this input. And now these inputs will be here. So all these are the different styles. And now I am giving some text, maybe a paragraph from here. So this paragraph, so now I have another, you can say I have all the styles now here, reading, narrating, emphasizing. I will use you all for reading, for narrating, for emphasizing. Emphasizing is putting focus on some parts of the sentence, on some words. So anyhow, so I have all these styles. So when that text will come here, then I will apply all these styles on that text. And then I have another audio file of this text that will have these different styles. Huh? Now here I don't have a text file. So that is the text file which I have given here. These different things which I stored here, different styles. Now I apply these styles on this text. And finally, I have a audio file in the reading, narrating, and emphasizing form. Um, for example, you normally write something in Google. You can write 2 sentences, and then if you will press the speaker, it will automatically the robot will automatically speak. So that is an application of speech synthesis. Okay, you can also do speech recognition. Speech recognition is something when you are speaking, your model will convert your speech into text. And if your model is able to convert your speech into text, that is something your model is recognizing your speech and converting it into text. Similarly, customer segmentation. Customer segmentation is dividing your customer, dividing. Even this speech recognition is purely an application of NLP, not the machine learning, but it is written here, okay? Because around us we have people who don't know and they are mixing these different things, okay? So now machine learning, NLP, AI, so everything is mixed. But actually, NLP is what? Actually, in the beginning, this was the subject only, NLP. But later on, the machine learning, a new uh, title emerged. And then now, after machine learning, we have another title, deep learning, that we have now in your age. So, but actually, you can say either machine learning or deep learning or information retrieval or big data, whatever. The mother is same, the NLP, you can say. Okay. Okay. NLP. NLP is basically the major domain under the umbrella of AI. So, anyhow, customer segmentation. This is another application in which you are dividing uh, customers into groups, or you are identifying customers based on different things. For example, demographics. What is demographic segmentation? Demographic segmentation is maybe age, religion, huh? So you can see ethnic, or so you can think of these different things, and that is called demographic segmentation. If you are, for example, you are uh, dividing people which have only age 20, or which have this religion, or which have these moral values. So, so this is what you are creating a group. So based on these different things, these different things which I stated. So that is called demographic segmentation. Similarly, behavioral or behavior segmentation. So normally, some people buy uh, very fashionable or trendy things, you can say. Some people buy only, okay, normal things, huh? Some people normally always like the brands or something like that. So what is the behavior of, from the data? From the data, you can identify that what is the behavior of the customer. What is the behavior of the customer? So that is, this is just only one example. So that is called behavioral segmentation. Psychographic, that is also, you can say, behavior. Normally you study in psychology, you study human behavior. So that's why psychographic is also, you will mix this segmentation with behavior. So uh, I can think anything. For example, uh, women's are normally buying more something related to makeup. Hmm? So that is their psychology. And maybe men are buying something, today's men, huh? Maybe something related to technology. So that is also a psyche of different customers. But it is not fixed for men or women. Some customers are buying technology type products. Some customers are buying makeup type things or whatever. So so based on their psyche, their psyche, if you are identifying some group from the data, that is called psychographic segmentation. Value based, it is easy according to the money, or according to their salary, or whatever, how much money they are spending, huh? So geographic is something related to the location or the area of the customer. And if you are doing segmentation, that is called geographic. Technographic, now something, uh, technology is a separate group also. So if some customers are interested in only in technology type things, then it is called technographic. Need based, or firmographics. So customers who are not buying too much, only the need-based products or whatever, that is something need-based. Firmographics related to some firms or organizations, and lifestyle stage. You can see the definitions of these different customer segmentations on the internet. Just write and then you will have that things there. So in machine learning, you can identify these different groups of customers. If you want to do that, that is also an application of machine learning. Object recognition. This picture is giving you an idea that if you have a picture, you will give this picture an input to your model, and that model will recognize what is that thing, what is that thing, what is that thing. So this is a person, this is a lamp or whatever. So it is identifying what are the objects existing in the picture. Similarly, fraud detection and prevention in the banks, recommendation of products. So this picture, when you will see that, you will get an idea about this saying. So normally, if you are visiting some sale purchase website, and if that sale purchase website is good, like Amazon, then it will automatically recommend some products to you, either in your email or when you are uh, doing search on that website. So these are the different applications of machine learning. Now moving next, now we are going to see that what are the uh, types of the, I don't know. Okay, it is running, yeah. So what are the types of the machine learning algorithms? Now we will see that in machine learning, what are the major four divisions. If you are going to build some model, that model will lie in one of these categories which we are going to study. So in machine learning, there are major four divisions, and every model that you will build will lie in any one of them. In any one of them. So the first category is supervised learning. So the first, so if you will build some model, that model will have some algorithm. Huh? So that algorithm will lie in any one of these four categories. And the first category is supervised learning. And then second category is unsupervised learning. And then semi-supervised learning. And then reinforcement learning. So these are the four major divisions. And now, if I will start from here, what is supervised learning? So in supervised learning, your data, this is your data now. In supervised learning, this is your model, this is your machine, and this is your model. So your machine or your algorithm will take this data, and this data in supervised learning, normally, whatever the model in machine learning is, normally these models has the training phase and the testing phase. So for the training, you have to give data to this model. And then this model will get training over it. And here we are giving this data to our machine. And that machine has this model. So this data in this supervised learning, the data that we are giving will have labels. For example, if this is the data of images, and these images contains rectangles, circles, hexagons, triangle, then we will also have the names that this is a rectangle, and this is what the circle, hexagon, triangle. So we also will give labels to those to those instances of that data. These are the instances. These are the instances of the data. This is just an example. And you are also providing the labels of this data in the input, in the input. And then you are giving this whole thing to your machine, which has this model. Your model, or you can say your machine will process this data, and this step is representing the training phase. Okay, that's why you have these symbols here, huh? That it is getting training. Huh? And after that, when it is trained, now your model is ready. Your machine learning model is ready to do the testing. And here we are giving the test data. In the test data, you are giving similar data to like that, which has the same type, but you are not providing the labels. You want that your model will predict that label automatically. Now you are giving this data, okay? You are not giving the names of this data. And then your model, as your model has already got the training on this data, so now your model is predicting that this is triangle and this is circle. Okay. Here you are not giving. This is your new data, unseen data. This data was not the part of this data. This is the new data, okay? And you have given this data now your model to your model, and your model is predicting that this is triangle and this is circle because your model has the training here. Your model know how what is you from this data. Your model know what is circle, what is rectangle, or whatever. So now, what is this definition saying? Take the data sample. So here your model is taking the data sample. What is that data sample? The training data, along with its output. This is basically the output, the names, labels. You can also call the labels with another name, output. So your model will take the training data and its output labels. The other name for this is labels or responses. With each data sample, with each data sample means this is one sample, this one sample, one sample. During the training phase. So now, what is supervised learning? Then you will say, in supervised learning, our model or model will take the data along with the labels. Along with the labels. And after getting training, then model will predict the labels of the test data. This is called what? Supervised learning. Supervised learning. So you have to keep this diagram in your mind. Then I think you will not do any mistake in defining the supervised learning. And what are the examples of different algorithms which are available for supervised learning? So these algorithms are k-nearest neighbors, naive Bayes, decision trees, linear regression, support vector machines, neural networks. These are the different names of the algorithms which are available for the supervised learning. For the supervised learning. Supervised learning has two categories. Further divisions, further divisions. Supervised learning has further divisions. First is classification, second is regression. I have not started the second category yet. Second category is unsupervised learning. So we are in the first category of supervised learning. And first supervised learning has further two categories, classification and regression. What is classification? When you are when your model is trying to predict only the category or categories from the data, then that would be called classification. Or when your model is trying to predict groups from the data. Groups from the data. I don't want to use the word groups because next clustering is coming and there I have to say this word there. So that's why, but it is something similar in some way. So classification is what? You have the data, and from that data you can make classes. That is one class, that is another class. So that's why it is called classification. Or in other word, if you want to predict categories or classes, categorical output labels or categories, you can say categories simply. What it means, let's see here. If your data has the emails, in your data you have emails, many emails, and you want to predict that email is spam or not spam. Now you want to identify two classes, spam or not spam. This is called binary classification because two classes. So if you identify from these emails that your email is spam or not spam, if you identify from the data, then, for example, you can see here feature one means feature one, feature two. Normally, feature means if the data is in tabular form, then the name of the column is the feature. Okay. Name of the column in your table is what? The feature. So if in machine learning that feature word will come, so you don't have to worry. You will always consider that feature is the name of the column. So, and normally if you have this X and Y, normally you write something X axis here, Y axis here. So you can say one column here, another column here, huh? Like you draw the charts in Excel, huh? And if you have a table in the Excel, then the names of the column will represent here or either on the X-axis or Y-axis, huh? So that's why you can understand if the word feature will come, you don't have to worry. Feature is something, the columns in your data. And now based, and those columns in your data will contain the text, the rows, the entries, the records. And when you will plot, and then you are saying that some emails are in, you have drawn, this is the visual display of that classification. You have drawn a line between these two classes because you want to identify two classes, spam and not spam. And here you have all the emails in this category, spam, and here you have all the emails in this category. So when you are going to do something like that, this is called classification. This is called what? Classification, because you are predicting what? Categorical output labels, or you can simply say categories. When we are going to predict categories from the data, then this is called classification. And what is regression? What is regression? When we are going to predict labels, here output labels, or the responses, it is same. When we are going to predict labels or responses, which here we are not talking about categories, which have continuous numeric values, What it means, for example, if you want to predict the price of house in Medina, maybe rent amount or whatever, renting amount of, because now the prices are quite high. I don't know either you are interested or not, but we people are interested because we always uh, searching to rent a cheap house or something like that, huh? So here you have some feature of the data. This is generally written here. And here on the y-axis, you are saying the price, which means maybe the rent of the house. And then for that, and this is something for one house, this is another, many houses. And how you can identify that now in this line, these houses which you are seeing here, so for example, this house has less renting amount, this has a little higher, this has a little higher, this has further higher, and so on. This is the highest one. Huh? How you can normally plot this diagram, and how I am calling that it is regression. Normally, this rent is according to the number of the bedrooms in the house. How many bathrooms are, how many halls, how many lounges, uh, and what is the total space, what is the covered area. These are the different things, huh? These are the different, these are the different things that you have to study, that which every house is containing. These are the different five, six different. I have spoken five different things. For example, number of bedrooms, number of bathrooms, halls, lounges, drawing room, total area, covered area. So based on this data, you can then, your model can predict that the price or the rent amount for this house should be this, huh? Or should be this, or should be this. If it is, if it is supervised learning, then here in your model, you will give some houses and also their their renting amount already. You will give them the labels because you want to uh, predict the renting amount of the house, huh? So you will give this information. Then your model will learn, and here it will predict the price of the amount. But that price for one house it can be lower, and for other it can be in between, and for some other it can be high. So so this price or this rent, it is not fixed. It is not fixed in one category. Huh? I cannot say that it should be in this category. Like here, that this email is spam or not spam. No any other thing. Huh? So here the renting amount, it can be 2K, it can be 5K, it can be 15, it can be 20, it can be 60, it can be 70 or 80, different amounts. Huh? So the amount is continuous. I cannot say that this is this is bounded in one category. No, I cannot say. So when your data is continuous, simply when your data is continuous, or when you want to predict something which is continuous, huh? Which is continuous, then this is not classification. Then it is called regression. Then it is called regression. I don't know either you have understood it or not. How many students have understood this regression? Raise your hands, please. Okay, Alhamdulillah. Number two, unsupervised learning. This is the second category of machine learning. The only difference between supervised and unsupervised is the input data, In the supervised learning, you have the data along with the labels. By the way, here I should have, you can remove this, huh? Here you have the data and here you have the labels. Okay. Now it is more clear, huh? Otherwise, maybe the only thing is in supervised learning, whatever the data you will give as input to this model for training, that data should be labeled, must be labeled, okay? Must be labeled. So, 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 but in unsupervised, it should not. Okay, this is not the condition. Your data in unsupervised, you will give unlabeled data. Here, and the rest of the thing is same. And when you are giving unlabeled data for the training of your model, now this is our model. For the training of your model, when you are giving unlabeled data, here we are giving the data, but we are not providing the names that this is orange, banana, or whatever. Huh? We are not providing these names. So here we are giving raw data without labels. But we will provide some information to this data
we will provide some information. And that information, we are calling it interpretation of this data. Interpretation of this data. For example, the leaves green, color orange. We will introduce, We will introduce the, for example, uh, color of leaves or color of body or shape, rounded or rectangle or square. What is the shape of that that fruit? So, so I have, so I want to get this extra information about this, about this data. What is the color of that, and how the shape of that? So I want to get this extra information. So this information, I am calling it interpretation. And in this unsupervised learning, I will call these things also features. Okay? Because when I say color, for apple, it is now red. For orange, it is now uh, yellow or orange color. And the shape is what? Here, orange has the circle or the rounded shape. That is almost circle, you can say. You will have some. So then what? You are introducing that color, shape. These are column names, So so I am saying that this interpretation would be what? It would be the features about the unlabeled data. And then, so in unsupervised learning, you will have the data, and then you will design some features about that data, or you can call it interpretation, but feature is better. And then you will run your algorithm over that data for the training. Okay? For the training. For the, actually here, this data, for it, we are not providing labels. So here in this model, there is no need to give test data, okay? Because this whole is the test data. This whole is the test data, because what do you want to predict from this? That this is an apple, this is orange, this is what you want to predict. And here we are not giving the labels to the data. Then what? This whole is like a test data to this model. So then there is no need to provide test data here in the diagram. But anyhow, but here you are interpreting this unlabeled data, which means you are introducing features, and those features will have information. And then your algorithm will run those features, or will understand things from the features and from this data automatically. It will learn, this model will learn the things from this unlabeled data and the features automatically during its training phase. And after that, it will take the same data and it will process that data, and it will separate the apples on one side and oranges on the other side. This is what we want to uh, categorize here in this example on unlabeled data. So the only difference between supervised and unsupervised learning is, in supervised learning, you have the labeled data, and in unsupervised, you have unlabeled data. And in unsupervised, you have this interpretation extra, which is the feature engineering, you can say. And in their, here in supervised, after giving data along with the labels, that your model is now learning, and now learning is complete, and your model is now ready to run on the test data. And here, there is no need to give test data separately, because this is like a test data, because you are not providing labels here. Your model has to predict these labels. You are only providing interpretations, which are the features, and then your model is learning. And then it is processing your data and separating these categories which you want. This is what, and examples are what? K means clustering. This is the name of the algorithm. K nearest neighbors. You were using this K nearest neighbors also here. K nearest neighbors, you were using this for the supervised learning, and now you are using for unsupervised. It is possible that you have one algorithm here which you are using for supervised learning can also be used for the unsupervised learning. Now, unsupervised learning has four categories, four divisions. First is clustering, and then is association, and then is dimensionality reduction, and then is anomaly detection. So, what is clustering? When I was explaining that classification, I said to you yeah, that I don't want to use that word, groups, huh? Because I want to use this word for clustering. Now imagine you have a data, and in your data, sometime based you have different things, and sometime, for example, here you have many people here, and now you want these are your customers, and you want to group these customers by their purchasing behavior. By their purchasing behavior. And these behaviors can be different. For example, these greens are those which are buying the things maybe under 5,000. 5,000 reals, you can say. This is one category. And then you have another category. These are the customers who are uh, buying only the mobile phones and the computers. And then you have another category. So behaviors can be different. Behaviors can be different. So based on these behaviors, you are identifying these groups from the data, And if you are doing something like that, that is called clustering. That is called clustering. So now you can read it and now you will understand. So you will either find similarity between the data, or you will find some relationship patterns in the data, and then you will cluster those samples of the data. This is one sample. This is another sample. This is another sample, okay? Or you can say then you are grouping those samples of the data. And the example is grouping customer by their customer behavior. In the picture, it is also shown. So this is called clustering. And this is the category of unsupervised learning. And then you have association. So association, again in the data, you have to identify something, you have to find some pattern or a relationship which would be between two or different things, okay? Two are different things in the data, in the data. So, for example, if I say I have association with Skandar, he's Pakistani, I am also Pakistani. So this is called association, okay? This is called association, relationship. So here in this association, analyze large data set. We will have to analyze data set, and then we have to find patterns. That patterns will represent what? Some relationship between different items of that data set. For example, here, the people who are buying some item X, they will also buy item Y. So there is a relationship between X and Y, these two products. Huh? There is a relationship. And this the people who are buying this coat, they are also buying these shoes. And the people who are buying this A plus B means milk and bread, they are also buying cheese. This is one relationship that you have identified from the data, from the sales data. From the sales data, you have identified that the people mostly who are buying these two things, they are also buying cheese. And the customers who are buying this coat, they are also buying this shoe. This is what you have identified from the sales data. This is called association. And this is also the second division of the unsupervised learning. And okay, the other name for it is association rule mining. Association rule mining. You can also call it association rule mining, or you can also call it market based analysis. This is the other names of the association. Moving next, dimensionality reduction. We have seen some word, some phrase in the previous slide, curse of dimensionality. Huh? We have seen this something on some slide. Curse of dimensionality. Here. Now that topic is here. Dimensionality reduction. Curse of dimensionality. What it means? There in the previous slide. What was the meaning of this curse of dimensionality? Okay, when your data is large or increasing, when the size of the vector is increasing, when the dimension of the vector is increasing. Vector is what? One-dimensional array. And that one-dimensional array is what here? For example, vector is representing the names of the columns of the database, of the data set that we have. Normally in machine learning, most of the time you will convert your data into the form of table first, and then you will process your data. Most of the time. Most of the time, okay? Whatever the data that you have, that you will convert your data into the form of a table, rows and columns, and then you will move further. And then writing all the names of the columns in one-dimensional array, that is called vector. Writing all the names of the columns in that one-dimensional dimensional array and then converting them into numbers is actually called vector, okay, in machine learning. I am now updating my definitions topic by topic, okay. Initially, I said vector is what? One-dimensional array which will contain the names of your columns of your table, of your data. And now I'm giving you a little updated definition. When you will convert the names of those columns in your one-dimensional array into numbers, 1 or 0, like that binary form, then it would be called vector, because vector is a numeric representation of your data. Anyhow, dimensional reduction. So when in the data, the number of columns are too much. When the number of columns in your data, and that data is in the tabular form, which means it will have the columns. When the number of columns in your data is large, then it means that your data, dimensionality of your data is large. And if the dimensionality of your data is large, then the machine learning model will take too much time in learning. So you have to reduce this dimensionality. You have to reduce this size. And when you will reduce that, this is called dimensionality reduction. This is called dimensionality reduction. And this topic, when your data dimensionality is large, this is called curse of dimensionality. And how you can reduce, there is some algorithms which is called PCA, principal component analysis, or the k nearest neighbors, or the discriminant analysis. These are the popular algorithms which are available to reduce the number of columns in your data, to reduce the number of columns in your data, to reduce the dimensionality of your data automatically. You don't have to think. Machine learning is not a subject in which you have to think too much. In machine learning is a subject in which the things are available. You only have to learn how to use them. Okay? How to use them. This is what you have to do. Machine learning is not about something intelligence. No. Machine learning is only how to use those tools intelligently. You don't have to program too much. You don't have to write big programs or whatever. You don't have to think that how that program will do the thing for you. No. You only have to learn how to use those tools. Because now things are already available. Already available. So now, so for example, here, if you will see this example, here you can see that this is the house, the size of the house. These are now some columns available in the data set of if you are going to predict the price of the house. Okay, you can take this example, price of the house. And this is one example. Size is one column, number of bedrooms is another column, number of bathrooms, crime rate in the neighborhood. Distance to the closest school. So these are the columns to predict the price of the house. Huh? But suppose that this is too much. Then how you can reduce? So then here we are combining these three into just one general size, and then we are combining these two into only the neighborhood quality. So we are keeping only the important ones, and the less important one, we are ignoring them. We are ignoring them. So in dimensionality reduction, the PCA, the principal component analysis, will do what? It will automatically detect the important ones and it will ignore the others ones. You don't have to think. When you will use this principal component analysis in Python, it is only a call to that function. And then you will give your input as you will give the data to as an input to this PCA, and it will do the things automatically for you. And similarly here, if it is some visual data and if it has X, Y, and Z 3 dimensions, and after reduction, it will have only X and Y direction, and then the pictures will be displayed in this format. Or it will have only the Z and Y, then the pictures will be displayed in this format. Okay. So it is giving you an idea that in dimensionality reduction, you have to reduce the size of the number of features available in your data. And feature is what? The name of the column. The name of the column. So by selecting, and it will reduce the number of features in our data by selecting only principal or important features, and it will ignore the others. Okay, now anomaly detection. So for example, anomaly has occurred. If I say, when I was doing this experiment, anomaly was occurred. So what it means? It means that when I was doing that experiment, something happened which is normally not happens. Okay. So then that thing which is not, that is unusual. So that unusual thing is called anomaly. So anomaly detection. So this is also the fourth category of unsupervised learning. What it is? We will use this approach to find out the occurrence of rare events, uneven events, or uncommon events, or unusual events. So in this category of unsupervised learning, we will identify the rare events or the observation that normally do not occur. But when occur, you have to identify. So identifying rare events is called anomaly detection. Simply, identifying rare events in the data is called anomaly detection. And what are its algorithm? So some of the unsupervised algorithm like clustering, whatever the algorithms that you have there in clustering, K means clustering is the name of the algorithm, or K nearest neighbor. So these, for example, these algorithms can detect what? Anomalies. It can detect anomalies. And how it can detect anomalies? Based on features. What is the meaning of the feature? Huh? Column names. I am giving you these simple words. It will give you the understanding easily of the different terms when you will study this subject. Maybe you have studied it already or not? You have studied? Okay, then there's no need. For example, here, aircraft engine features, and here X1 is a feature, is a variable, is a feature which has the value heat generated. X2 is another column name or feature which has what is this column for? This X2 will contain the vibration intensity. When the engine is running, vibration intensity. X1 is what? Heat generation. How much heat is produced? Maybe so this X1 will have the value in the form of 90 degree or something like that. This is just an explanation what this column is, and so on. And you have the data X1, X2 up to on going on like that, X1, X2 up to XM. This is the data set. And this is the data set for your model, and now your model has completed its training, and now your model is ready to be tested on the test data. And now you are giving some test data which is X. You are giving a new engine has arrived, and now you are testing that engine. And when you are running and your model, machine learning model, is running over that data, and then it is predicting this column is X1, which is this one, and this column is X2, which is this one, and your model is plotting all that data from X1 to XM here. These crosses with the brown color or red color or something like that. And this is your test data, which is green color. And if your test data is plotted between these red crosses, then it means okay, it is in between the same range where the other data is, where the other data is lying, because this is the boundary of the data. And if the new test data is the new engine, when you have given the data of this engine to the model, your model has plotted here in between this data, then it means okay, no anomaly, everything is okay. But if your model will plot this a little far from this data, in the plot, when it will plot a little far from that data, which is the data set, which is the representation for the data set, then this would be as a uncommon event or rare event, or you can call it that now this is the anomaly. This is the anomaly. And these algorithms, KNNs, or some clustering algorithm you can use to detect this anomaly. To detect this anomaly. And I will start here in the next lecture, inshallah. Semi-supervised learning.